Hi, Stats. Sorry, I'm going to be missing our lesson today. I hope you had a good Thanksgiving break. I'm going to go through section 5.2 with you. A lot of times I'm going to ask you to pause the video, work ahead, and do that because at the end of the block today, I'm going to ask you to turn in an exit ticket that I'm going to look at and potentially grade. So on this first page, you're going to notice some things that we talked about in the last lesson: probability model, complement, two-way table, Venn diagram. You've probably heard of that stuff. Some you haven't. We talked about mutually exclusive. So first, we're going to just describe a probability model, use basic probability rules, and I just kind of want to rehash what we talked about before break, just to get you thinking about things. So first, explain what the complement rule is below, and then what's the notation that we use. So I'd encourage you to pause it now and just write down what you think. All right, so the complement rule is essentially the probability that the event will not happen. And it's denoted by this probability of A, C for complement. That's the probability of not A. All right. Explain what it means for two events to be mutually exclusive. If you can, give an example. So again, pause the video, see if you can write down what that is. If you need to, look back at lesson 5.1. So two events mutually exclusive means they have no common outcomes. They cannot happen at the same time. You cannot roll a die and get a 5 and a 6 at the same time. It's impossible. So that's what it means to be mutually exclusive. The two events share no common outcomes. So what I'm going to encourage you to do now on the bottom of page 1, this is all review from section 5.1. Some of this same thing is in section 5.2. Take out your 5.1 lesson, use that to answer these questions, and then come back and check in, and I'll go through these with you. So on this one, explain why the probability model is valid. There's two things that you're doing. Checking to see, are all the probabilities between 0 and 1? They are. And is the sum of the probabilities equal to 1? They are. So this is a valid probability model. Answer the following questions using correct notation. So what's the probability somebody did not score a 3? It's the probability of 3 complement. 1 minus the probability that they did earn a 3. What's the probability that somebody scored a 4 and a 5? Well, these events are mutually exclusive. It's impossible to get a 4 and a 5. So that probability would be 0. Let me focus this in a little bit more. And the last one is a little bit different. It talks about the probability they score a 4 or a 5. So I'm going to take the probability that they score 4 plus the probability that they score a 5 and get that almost 35%. All right, I'm going to move on to that second page. This is going to get into some new information. So our goal here is to use a two-way table or a Venn diagram. As we get further into the lesson, you're going to hear me say Venn diagrams, not really a fan of. I'm going to try to avoid those like the plague. Just I don't think they're as informative as the two-way tables. And use this general addition rule, which we're going to kind of investigate. Okay, so we're going to talk about these two events. Taco tongue, which is rolling your tongue like, can you do it? Can you not do it? I don't know. Everyone in my family can do it except my mom. An evil eyebrow is a little more subjective. Like, I don't think I can evil eyebrow. I'm too nice of a person, I think. Anyways, so I had to make up the class data since I'm not going to be there to do this. So say we have this two-way table based on our class data. So what we're going to do first is take this information and put these 4 numbers inside the two-way table into the corresponding spots of the Venn diagram. So in order to do this, I need to start thinking about where these are going to go. So what I'd encourage you to do, use a pencil, pause the video, and see if you can fill in these 4 numbers in the middle of the table where they go here, and then check as I talk through it and see if you got them right or wrong. I'm going to start with the easiest. Yes, evil eyebrow, and yes, taco tongue. That's going to be the intersection. So the 4 is going to go there. The other one that's easy is no evil eyebrow, no taco tongue. There's 3 students who couldn't do either. That's going to go outside of the circles, but inside of the rectangle. The other 2 now should be a little bit more straightforward. Yes, taco tongue has to be within the taco tongue circle. So there's 11 students. There's 15 total. The 4 plus the 11 is where the 15 comes from. And now here, there's 6 who could evil eyebrow. So you have 2 that could evil eyebrow but couldn't taco tongue, so the 2 goes there. All right, what I'm going to want you to do now is go ahead and use the two-way table. I think that's a little easier to find the probabilities, and answer all of question 2 and all of question 3. So pause the video now, go ahead and do that, and then check back in and I'll go over those with you. All right, so yes, taco tongue would just be the 15 out of 20. 15 people could taco tongue out of 20 total. No is the complement, 5 out of 20. Yes, evil eyebrow, 6 out of 20. No evil eyebrow, 14 out of 20. Now we get into ands. Yes, taco tongue and evil eyebrow. So I'm looking at the intersection of both. There's 4 students out of everyone. Yes, taco tongue and no evil eyebrow. So now I'm looking at yes, taco tongue, no evil eyebrow. They intersect here at 11. So there's 11 students out of 20. Yes, evil eyebrow and no taco tongue. So yes, no. We're looking at 2 out of 20. And yes, taco tongue. I'm sorry, no taco tongue, no evil eyebrow, no, and no. We're looking at 3 out of 20. Oh, let me move that. All right, moving on to the second question, or I guess question 3 actually. Yes, evil eyebrow, 6 out of 20. No evil eyebrow, 14 out of 20. You already did that up there. Yes, evil eyebrow or no evil eyebrow. Well, these are just complements. You either can or you can't. So when you sum them up, you get 20 out of 20 or 1. Everyone in the class can either do it or not do it. So what I want you to do now on page 3 is answer question 4. Do this, come back to the video. We'll check it in a moment. So now it's saying probability of yes, taco tongue. All right, so I got too many pages here. Yes, taco tongue. That's 15 divided by 20. Yes, evil eyebrow. 6 divided by 20. Yes, taco tongue or evil eyebrow. Okay, so 15 out of 20 plus 6 out of 20 is 21 out of 20. I'm assuming at least one person in the class did that because that's what we've done. We have mutually exclusive events. We add up their probabilities. Here's the problem. These aren't mutually exclusive. You could have a student who could taco tongue and evil eyebrow. And hopefully you recognize like, wait, this is wrong. This is bigger than 1. Probability can never be bigger than 1. So what we have to do, the problem is we're double counting these 4 students as part of the 15 and the 6. So what we do here is we subtract that overlap. We subtract those 4 students who are in both groups to get 17 out of 20. And that's going to be the probability that somebody can taco tongue or evil eyebrow. That, remember, or we haven't learned that yet, so you can't remember that. So, big ideas. Taking a two-way table and being able to put those numbers into a Venn diagram. The only time I'd advise using a Venn diagram is if they literally force, like say, using a Venn diagram. This general addition rule, I don't get too hung up on formulas. You don't need to. This is on your green formula sheet, but I'm not going to kind of force it. The probability of A or B is the probability of A plus B. If the events are mutually exclusive, we stop there because the probability of both is 0. That's what we saw in lesson 5.1. But if there is overlap, like the question we just did here, you have to subtract the probability of that overlap. So we're going to practice this one quite a bit throughout this lesson. All right, let's move on to page 4. This is just to check your understanding based on what we just talked about. So what I want you to do, pause the video, take 5 minutes or whatever it's going to take you, work through this, check your understanding, come back, and I will explain it. Question 1, explain in plain language what this means and find the probability. First of all, I needed to take this two-way table and I needed to figure out the totals. So I summed up each row, or each column, each row, and then the grand total, which they told us already was 500. I see that C, that means complement. So this means the probability somebody is not a high school graduate. So there's 310 out of 500 that were high school graduates. So not a high school graduate, 190 out of 500. Don't bother reducing, don't bother simplifying, just leave all your probabilities as is. It's okay on tests, quizzes, AP exam. Number 2, explain why these are not equal and then find the probability. Well, G is graduate, H is homeowner. These are not mutually exclusive. We have high school graduates that are homeowners. So the reason is the events G and H are not mutually exclusive. You can be a high school grad and a homeowner. So just using that formula, it's the probability that they're a high school graduate, 310 out of 500, plus the probability they're a homeowner, minus the probability of both. So this is the probability they're a grad, plus the probability they're a homeowner, minus the probability that they're a grad and a homeowner. There's other ways to do this without the formula. Or just means one or the other or both. So you can think about it this way. It's going to mean both, just a high school grad, just a homeowner. You could just add up those numbers divided by the 500. I don't care how you get it, show your work, but you don't have to use that formula. The last part, write this event in symbolic form and find the probability. Probability that they're not a high school graduate, so graduate complement, and is a homeowner. So if they're not a graduate, we're looking here, and a homeowner, we're looking here. We're looking at that intersection, 119 divided by 500. So I'm going to stop the video here and make a new one for the second part of the lesson.